In the previous video, we have seen how to search an item in the linked list. In this video, we will see how to reverse the entire linked list. Consider this linked list. So when we reverse the linked list, this is how the linked list will look like. So every node will point to its previous node and head will point to the last node. So how can we achieve this? First, we need to have three pointers here. One is previous, next is current, and next is next. So starting previous will point to null. So we need to have null here so that this first node can point to null, and the current will point to the head to start with, and we will have next as the current dot next. So this is how we start. So we need to point this pointer to null. So I'll point to whatever current dot next is pointing to previous. Next step is we need to advance the previous. So this pointing is done. So there is no use of previous here. So I'll advance previous to current. Once previous is pointing to here, we need to advance this current as well. So current will point to next. So this is how we can reverse one node. We have two more nodes to reverse. Let us see that in the next slide. So this is how our linked list is currently. Now we will repeat the step. First step is to point the next pointer to current dot next. So I have moved this next pointer. Now we need to point this pointer to previous node. So I have done that. Now we need to advance this previous. I have advanced this previous, and finally we need to advance the current. So we have reversed two nodes, and finally we need to reverse the last node. So this is how it looks like now. The first step is to point the next to the current dot next. I've advanced the next. Now we will point this 30 to 20. So I've reversed this link. Now we need to advance previous to current and current to next. I'll do that in single step. So now previous has moved here and current is pointing to null. So whenever current points to null, we will exit our loop. Now the linked list is reversed. Only one problem we have, that is head is not pointing to the first node. So what we do is we update this head with the previous pointer. So now the linked list is completely reversed. Let us go ahead and code this. So I'll write the reverse method. This will not receive anything. So the first thing here to do is point previous to null. Let previous is equal to null, and I'll point current to head. Now we need to start looping. So I need to check while current not equal to null. Now I need to point next to current dot next. So I'll declare next as current dot next, and I need to point current dot next to the previous node. So that would be current dot next is equal to previous. Once this link is done, we need to advance previous. So previous will be current. Previous is equal to current. So we are done with this step. And finally, we need to advance current to next. So that would be current equal to next. And we shouldn't forget the last step where we'll point head to the previous node once all the looping is done. So outside, this dot head will point to previous. That is the first node in the reversed linked list. So that is the reverse function. I know it's a bit complicated. You can go through the video again to understand it better. Now let us test this. So I'll insert a few more values before reversing it. So I'll do linked list dot append of 70 and 80. Let us just print it. So this is how our linked list looks like. Now I'll reverse it and I'll print it. So as you can see, the linked list is reversed. So it is 80, 70, 60, 35, and 30. So that's it about linked list operations. In the next video, we will see linked list with tail. As we have seen, whenever we want to append, we will traverse through the list, which is having a time complexity of big O of n. To avoid this, we will have a tail pointer where we can just directly append with a constant time complexity. Before going to the next video, let us see some pointers that will be helpful while implementing linked list. First thing is the head should always point to the first node in the list, and we should update head only in three scenarios. One is we are adding a node at the start, or removing the node at the start, or we are reversing the list. In any other case, we will not be updating the head, and we will always use a previous or current pointer. And while making connections, make sure that you are first updating the node which is pointing to null, and then only we are updating the other node. That means in the case of insertion, first we need to point this node to the node 30, and then only we need to remove this node. If we first remove this node and point it to here, then we will not get reference to this node and we will lose it. So first always point whatever is pointing to null, we point here. So ensure that whichever node we need to retain, we need to have at least one connection to it, then only remove the other connection. Hope you're liking this series. If you are, please consider subscribing to the channel. See you in the next one.